22nd of December, 1942, the acrid smell of gun oil and cordite hung in the cold air of the Imperial Japanese Army's Technical Research Institute in Tokyo as Colonel Nambu Kijiro watched his team of engineers carefully disassemble the captured American rifle laid before them on the examination table. The weapon, an M1 Garand, had been recovered from a battlefield on Guadalcanal 3 weeks earlier, still clutched in the hands of a fallen Marine. What these engineers were about to discover would send shockwaves through the highest levels of Japanese military command and reveal a technological gap that would haunt the imperial forces for the remainder of the Pacific War. The colonel adjusted his spectacles, leaning closer as Lieutenant Yoshida Takeshi, the Institute's lead firearms specialist, began his initial assessment. Yoshida had spent 15 years studying small arms design, including a stint in Germany before the war where he'd examined European weapons development. Yet nothing in his extensive experience had prepared him for what he was now holding. The weight distribution felt different, more balanced than the bolt-action Type 38 Arisaka rifle that Japanese infantry carried into battle. As he worked the action, his expression shifted from professional curiosity to something approaching alarm. "Colonel," Yoshida said quietly, his voice barely masking his concern, "this weapon cycles automatically. Each pull of the trigger fires one round, and the rifle chambers the next without manual operation." In the corner of the laboratory, Captain Tanaka Hiroshi meticulously documented every measurement, every specification, every mechanical detail in his logbook. Tanaka had been skeptical of American industrial capabilities, repeatedly assured by propaganda that Japanese craftsmanship remained superior in every regard. The precision machining he now witnessed told a different story entirely. According to documentation later referenced in historian John McManus's Grunts, inside the American infantry combat experience, World War II through Iraq, Japanese military analysts had consistently underestimated American weapons technology, a miscalculation that would prove costly on every island battlefield across the Pacific. The examination continued throughout the afternoon as the team methodically tested every component. Major Watanabe Kenji, who specialized in metallurgy, subjected metal samples to stress tests, measuring tensile strength and durability under extreme conditions. His findings troubled him deeply. The American steel demonstrated superior quality, able to withstand heat and pressure that would compromise Japanese-manufactured components. The en-bloc clip system, which allowed for rapid 8-round loading, represented an innovation that Japanese designers had never seriously pursued. As darkness fell over Tokyo, Colonel Nambu compiled the day's findings into a preliminary report. The numbers painted an undeniable picture of tactical disadvantage. Where a skilled Japanese rifleman using the bolt-action Arisaka could fire perhaps 15 to 20 aim shots per minute, requiring manual manipulation of the bolt after each round, an American soldier with the semi-automatic M1 Garand could maintain a sustained rate of 40 to 50 rounds per minute with minimal effort. The implications for infantry combat were staggering. In any engagement, American forces could theoretically deliver 2 to 3 times the volume of rifle fire. But the technological superiority extended beyond mere rate of fire. The Garand's effective range, accuracy, and stopping power all matched or exceeded the Arisaka's capabilities while adding the crucial advantage of semi-automatic operation. Nambu recognized immediately that this intelligence needed to reach the highest command levels, though he suspected that such unwelcome news might be dismissed or downplayed by officers who had invested their reputations in assertions of Japanese military superiority. 7th of January, 1943, Lieutenant Colonel Arisaka Nariokira, whose uncle had designed the Type 38 rifle decades earlier, sat in uncomfortable silence as he reviewed Colonel Nambu's complete analysis in his office at the Army Ministry. The morning sun streamed through the windows overlooking the palace grounds, but Arisaka felt only coldness as he confronted the reality that his family's legacy weapon had been rendered obsolete by American innovation. The rifle that bore his family name, adopted in 1907 and still serving as the standard infantry arm 36 years later, now appeared woefully inadequate for modern warfare. The Type 38 Arisaka had been designed during a different era, when Japanese military planners prioritized certain characteristics over others. Its 6.5mm cartridge produced less recoil than larger rounds, making it easier for smaller-statured soldiers to control an important consideration, given that the average Japanese infantryman stood approximately 5 feet 3 inches tall and weighed around 120 pounds. The rifle's length, nearly 50 inches, incorporated a long barrel that maximized accuracy and muzzle velocity while requiring less propellant, conserving resources in a nation that needed to import most raw materials. According to research documented in historian Max Hastings's Retribution, The Battle for Japan, 1944 to 1945, Japanese military doctrine had emphasized spiritual strength and fighting spirit, what they called seishin, as force multipliers, that could overcome material disadvantages. This philosophy, deeply rooted in samurai tradition and Bushido code, led commanders to believe that superior morale and tactical aggression could compensate for inferior weapons. The M1 Garand's performance on Guadalcanal, Tarawa, and dozens of other battlefields was systematically dismantling this assumption. Arisaka reviewed reports from various combat zones, each telling similar stories. At close range in jungle terrain, where visibility rarely exceeded 50 yards, the semi-automatic rifle provided devastating advantages. American infantrymen could maintain continuous fire during charges, suppressing Japanese positions while advancing. Japanese soldiers, by contrast, had to work their bolt actions after each shot, creating crucial seconds of vulnerability. In defensive situations, a single American rifleman could hold off multiple attackers through sheer volume of fire, something impossible with bolt-action weapons. The industrial context made Japan's predicament even more dire. John Toland's The Rising Sun, The Decline and Fall of the Japanese Empire, 1936 to 1945, provides insight into Japan's manufacturing limitations during this period. Even if Japanese engineers could design a semi-automatic rifle comparable to the Garand and several experimental models existed, the nation's overstretched industrial base couldn't produce such weapons in meaningful quantities. Every factory, every skilled worker, every ton of steel was already committed to building ships, aircraft, artillery, and tanks. Retooling for a completely new rifle system while fighting a multi-front war was effectively impossible. 16th of February, 1943, across the Pacific Ocean in Springfield, Massachusetts, Foreman Robert Henderson watched the overnight shift at Springfield Armory assemble another batch of M1 Garand rifles destined for troops fighting in North Africa and the Pacific. The facility hummed with industrial energy, its assembly lines representing American manufacturing might at full wartime mobilization. Henderson had worked at the armory since 1928, witnessing the long development process that had transformed John Garand's initial concept into the weapon now pouring off production lines at a rate of 4,000 rifles per day. The rifle's journey from concept to standard issue had been neither quick nor simple. Canadian-born John Cantius Garand had joined Springfield Armory in 1919, tasked with developing a semi-automatic rifle to replace the bolt-action then 1903 Springfield. His early prototypes faced skepticism from conservative military officers who doubted that semi-automatic mechanisms could prove reliable under combat conditions. The Army conducted exhaustive testing throughout the 1920s and 1930s, comparing Garand's designs against competing submissions from other inventors. What ultimately convinced military leadership, according to documents referenced in Bruce Canfield's A Collector's Guide to the M1 Garand, and the M1 Carbine, was the Garand's combination of reliability, accuracy, and manufacturability. The rifle utilized a gas-operated mechanism where expanding gases from each fired cartridge drove a piston that automatically ejected the spent casing and chambered a fresh round. This system, simpler than competing designs, proved robust enough to function in mud, sand, rain, and extreme temperatures. The Army formally adopted the M1 in 1936, beginning a production ramp-up that would eventually deliver over 5 million rifles before war's end. Henderson understood that the rifle's real genius lay not just in its design, but in how that design accommodated mass production. Every component had been engineered for efficient manufacturing using the standardized machinery and processes available in American factories. The receiver was machined from forged steel using automated milling operations. The wooden stock could be shaped and fitted by semi-skilled workers following precise specifications. Parts were interchangeable between rifles, allowing field maintenance without custom fitting. This production-friendly design meant that Springfield Armory and Winchester Repeating Arms Company could collectively produce enough rifles to arm the rapidly expanding American military while maintaining consistent quality. The economic context made this possible. While Japan struggled with resource shortages and competed for limited industrial capacity, America's manufacturing sector had been dramatically underutilized during the Great Depression. War mobilization transformed idle factories into weapons production facilities practically overnight. Steel mills in Pittsburgh, automotive plants in Detroit, and specialized machine shops across the industrial heartland all contributed to the war effort. The United States could simultaneously produce ships, aircraft, tanks, artillery, ammunition, and small arms in quantities that simply overwhelmed Axis production capabilities. Technical Sergeant William Bradford, an ordnance specialist stationed at the armory, explained the rifle's combat advantages to a group of visiting journalists that February morning. "The M1 gives our boys 8 shots as fast as they can pull the trigger," Bradford said, working the action to demonstrate. "No fumbling with a bolt between shots. No taking their eyes off the target. No breaking their firing position. In combat, those seconds matter. They're the difference between living and dying." Bradford had reviewed after-action reports from North Africa, where American forces first encountered German troops in significant numbers. While German soldiers carried the excellent Mauser K98 bolt-action rifle, generally considered superior to the Japanese Arisaka in power and accuracy, they still faced the same fundamental limitation of needing to manually cycle the bolt after each shot. American infantrymen with M1 Garands could deliver suppressive fire that pinned German soldiers in place, enabling tactical maneuvers that would have been far more difficult with bolt-action weapons. The rifle's 8-round en-bloc clip system, while sometimes criticized for the distinctive ping sound it made when empty, provided rapid reloading capabilities. A trained soldier could eject an empty clip and insert a fresh one in under 3 seconds, maintaining nearly continuous fire during engagements. Japanese soldiers, by contrast, loaded their Arisakas with individual rounds or 5-round stripper clips, a slower process that created dangerous gaps in defensive fire. 3rd of March, 1943, in a secure conference room deep within the Army Ministry, General Tojo Hideki listened with increasing displeasure as Colonel Nambu presented his findings to a gathering of senior officers. Tojo, serving simultaneously as Prime Minister and Army Minister, had built his career on the premise that Japanese spirit and tactical excellence could overcome material disadvantages. The suggestion that American weapons technology had created an insurmountable advantage challenged fundamental assumptions underlying Japan's entire war strategy. The atmosphere in the room grew tense as Nambu displayed comparative firing rate calculations, range effectiveness data, and battlefield performance assessments. Major General Kimura Heitaro, responsible for infantry equipment procurement, attempted to contextualize the problem within existing constraints. "We are not unaware of semi-automatic rifle technology," Kimura explained, his voice careful and measured. "Our engineers developed experimental models before the war. The Type 4 and Type 5 rifles showed promise in trials. However, these designs require precision manufacturing that demands resources we cannot spare. Each semi-automatic rifle requires approximately 3 times the machine hours to produce compared to an Arisaka, uses higher-grade steel, and needs more skilled labor for assembly." The economic arithmetic was inescapable. Japan's war economy operated under severe limitations that American planners could scarcely imagine. The home islands possessed minimal natural resources, virtually no oil, limited iron ore, scarce rubber, and insufficient food production to feed the population without imports. Everything required for modern warfare had to be extracted from conquered territories in Southeast Asia and China, then transported through sea lanes increasingly threatened by American submarines. According to analysis presented in Richard Frank's Downfall, the end of the Imperial Japanese Empire, Japan's steel production in 1943 totaled approximately 7 million tons compared to America's 89 million tons, a 12-to-1 disadvantage that constrained every aspect of military production. Lieutenant Colonel Nambu Yoshimoto, a logistics specialist, provided additional sobering details. Even if we could manufacture semi-automatic rifles in quantity, the ammunition consumption would strain our supply system beyond capacity. The M1 Garand's effective combat usage consumes 2 to 3 times more ammunition than bolt-action rifles. Our logistics network, already stretched to maintain current operations across China, Southeast Asia, and the Pacific Islands, could not sustain such increased demand. American production vastly exceeds ours. They can afford to expend ammunition liberally while we must conserve every round. This supply reality shaped tactical doctrine in ways that American troops exploited ruthlessly. Japanese soldiers received strict instructions to make every shot count, firing only at clearly identified targets with high probability of hits. Conservation of ammunition was drilled into troops as both practical necessity and moral imperative. Wasting bullets meant betraying comrades who depended on those supplies. American soldiers, by contrast, could employ suppressive fire tactics, spraying areas with bullets to pin down enemies even without clear targets, knowing that ammunition resupply was reliable and abundant. General Tojo listened to these explanations with visible frustration. He had staked his political reputation on Japan's ability to fight the Western powers to a stalemate, forcing negotiations that would preserve territorial gains. Every admission of technological or industrial inferiority undermined the narrative of Japanese destiny and racial superiority that justified the war effort to the population. What alternatives exist? Tojo demanded. We cannot simply accept that our soldiers enter battle with inferior weapons. What can be done to address this disparity? Colonel Sakurai Tokutaro, who had studied American manufacturing methods during a pre-war intelligence posting, offered a bleak assessment. Excellence, General. Their advantage stems from industrial capacity we cannot match during wartime. Their factories produce more of everything: ships, planes, tanks, rifles, ammunition. The M1 Garand represents merely one example of this broader superiority. Even if we could match their rifle design, we would still face disadvantages in artillery, air support, naval gunfire, logistics, and every other material category. The fundamental problem is not the rifle, it is the industrial base that produces it. This strategic reality had been apparent to some analysts even before Pearl Harbor. Admiral Yamamoto Isoroku, architect of the Hawaii attack, had warned that Japan could compete successfully for 6 months to a year, but that prolonged conflict would favor American industrial might. Those predictions were proving accurate. By early 1943, American production was reaching full wartime mobilization, while Japanese output had peaked and begun declining due to resource shortages and submarine interdiction of supply routes. The meeting concluded without resolution. General Tojo ordered continued development of improved weapons but acknowledged that major changes to standard infantry equipment were impractical during wartime. Japanese soldiers would continue carrying Arisaka rifles, Type 99 light machine guns, and other existing weapons regardless of their limitations compared to American equivalents. 19th of April, 1943, Private First Class Yamamoto Ichiro crouched in a hastily dug fighting position on the northern coast of New Georgia Island in the Solomon Archipelago, gripping his Type 38 Arisaka rifle with hands that trembled despite his best efforts at control. The 20-year-old farmer's son from Niigata Prefecture had been in combat for 11 days, and in that time he had learned terrible lessons about the gap between training doctrine and battlefield reality. The distant rumble of American naval guns provided continuous reminder that the enemy possessed resources Japan could never match, resources that included the semi-automatic rifles carried by the Marine infantrymen now advancing through the jungle toward his position. Yamamoto had graduated from basic training at the top of his company, praised by instructors for his marksmanship and ability to work his rifle bolt with practiced efficiency. On the training range, he could fire aimed shots at a rate that satisfied his sergeants, cycling the bolt smoothly between rounds, maintaining proper breathing and trigger control. Those instructors had emphasized that Japanese soldiers didn't need semi-automatic rifles because superior training and fighting spirit made each shot count. The enemy, they claimed, relied on wasteful spray and pray tactics because American soldiers lacked discipline and skill. Combat had exposed these claims as dangerous fantasies. 3 days earlier, Yamamoto's squad had attempted to ambush a Marine patrol moving along a coastal trail. His sergeant, Corporal Sato, had positioned 8 riflemen in concealed positions with overlapping fields of fire, following textbook infantry tactics. The Marines appeared, moving cautiously through the tropical vegetation, and Sato gave the signal to fire. Yamamoto squeezed his trigger, felt the Arisaka's mild recoil, worked the bolt to chamber the next round, and aimed at another target. In those few seconds, perhaps 3 or 4 at most, the jungle erupted with such intense return fire that Yamamoto thought his squad faced an entire company rather than a patrol of perhaps a dozen men. The distinctive crack of M1 Garand fire came from multiple directions simultaneously, each American Marine firing continuously without the pause required to work a bolt action. While Yamamoto struggled to acquire his second target, the Marines had each fired 5 or 6 rounds, their bullets shredding the vegetation around Japanese positions with such volume that returning fire became nearly suicidal. Private Tanaka, positioned 3 meters to Yamamoto's left, raised his head to aim and took a round through the neck before he could fire a single shot. The ambush had failed catastrophically, 2 Japanese soldiers dead, 3 wounded, the survivors retreating in disorder while the Marine patrol maintained continuous fire throughout their withdrawal. Sergeant Watanabe Takeshi, a veteran of fighting in China, had tried to explain the tactical implications during a quiet moment the following day. Against Chinese forces with bolt-action rifles or older weapons, our tactics worked because we had rough parity and firepower, Watanabe said, his voice heavy with fatigue and something approaching despair. But the Americans, they change everything. One American rifleman can suppress multiple positions because he doesn't have to stop firing to reload. They advance under covering fire that never stops. We cannot fire back without being immediately targeted by 3 or 4 rifles simultaneously. The ammunition disparity compounded the problem. Yamamoto carried a standard combat load of 150 rounds for his Arisaka, distributed in 5-round stripper clips and individual rounds in his cartridge pouches. He had been explicitly instructed to conserve ammunition, firing only at clearly identified targets with high probability of hits. American Marines, by contrast, seemed to fire almost casually, using bullets to suppress suspected positions, probe defensive lines, and maintain continuous harassment. According to accounts later compiled in George Macmillan's The Old Breed, a history of the 1st Marine Division in World War II, Marine riflemen typically carried 80 to 120 rounds of Un-1 ammunition in en-bloc clips, but supply arrangements ensured they could request and receive much more during sustained combat. That afternoon, Yamamoto witnessed the consequences of this firepower disparity during a larger engagement. American forces launched a coordinated attack on the Japanese defensive line with combined arms support that defied comprehension. Naval gunfire from offshore destroyers pounded defensive positions for 30 minutes, the massive explosions throwing dirt, splintered trees, and shredded vegetation high into the air. Then came artillery fire from mobile guns the Americans had somehow brought through jungle terrain that Japanese planners assumed was impassable for heavy equipment. Finally, the infantry advanced behind a wall of small arms fire that never seemed to diminish. Yamamoto fired at approaching figures, worked his bolt, fired again, worked his bolt again. Beside him, Private Suzuki fired methodically, each shot carefully aimed despite the chaos around them. But across the battlefield, American Marines fired continuously, their M1s delivering such sustained fire that Japanese soldiers had to remain low in their positions rather than rising to aim properly. The psychological impact was devastating, the sense of being outgunned, outnumbered, and overwhelmed by an enemy who could afford to waste bullets because they had so many to waste. 27th of May, 1943, Lieutenant Commander Kurosawa Akira, assigned to the Naval Technical Research Institute in Yokosuka, examined a second captured M1 Garand that had been recovered from an American aircraft shot down near Rabaul. The Navy maintained its own weapons assessment program separate from the Army, and Kurosawa's team had reached conclusions that aligned disturbingly with their Army counterparts' findings. As he methodically tested the rifle's gas system, measuring pressures and cycling rates, Kurosawa understood with absolute clarity that Japan faced not merely a tactical disadvantage, but a fundamental technological and industrial deficit that could not be overcome through ingenuity alone. Kurosawa had studied mechanical engineering at Tokyo Imperial University before entering naval service, and he approached weapons analysis with scientific rigor that sometimes frustrated officers who preferred simple answers to complex problems. The Garand represented the culmination of decades of American firearms development, incorporating innovations that solved problems Japanese designers had barely begun to address. The gas-operated mechanism demonstrated elegance in its simplicity. Expanding gases tapped from the barrel drove a piston that provided just enough energy to cycle the action without creating excessive stress on components. The timing was precise, the parts worked in harmony, and the system proved remarkably forgiving of dirt, moisture, and abuse that would jam more delicate mechanisms. What impressed Kurosawa most was the manufacturing philosophy embedded in the design. Every component reflected considerations about mass production parts that could be machined efficiently, tolerances that allowed for slight variations without affecting function, assembly processes that minimized skilled labor requirements. The Americans had designed not just a weapon but an entire production system that transformed raw materials into finished rifles with industrial efficiency that Japanese manufacturers could not approach. He documented these observations in detailed technical reports, including precise measurements and metallurgical analyses. According to research presented in C.J. Chivers' The Gun, the Ko-47, Superweapons and the Making of Modern History, Japanese weapons designers recognized American engineering excellence but found themselves unable to replicate it under wartime constraints. Even when Japanese engineers created successful experimental weapons such as the Type 4 and Type 5 semi-automatic rifles, these designs required manufacturing capabilities that exceeded what Japanese industry could provide while meeting existing production commitments. Commander Tanaka Yoshio, who oversaw the research program, reviewed Kurosawa's findings with resignation that bordered on fatalism. "Your analysis confirms what we have suspected," Tanaka said quietly, his office overlooking the naval base where half-completed warships sat idle due to steel shortages. "American industrial capacity exceeds ours by such margins that comparison becomes almost meaningless. They can afford to give every infantryman a semi-automatic rifle. They can afford to supply enough ammunition for liberal usage. They can afford the shipping to transport these weapons and supplies across the Pacific. We cannot afford any of these things." The ammunition question particularly troubled Kurosawa. His calculations indicated that American forces consumed rifle ammunition at approximately 3 times the rate of Japanese forces simply due to having semi-automatic weapons. American factories produced enough ammunition to support this increased consumption while still maintaining large reserves. Japanese ammunition production, by contrast, could barely keep pace with current consumption rates using bolt-action rifles. Transitioning to semi-automatic weapons would require tripling ammunition output impossible given current industrial capacity and raw material limitations. Kurosawa also examined the M1 carbine, a lighter weapon issued to American officers, NCOs, vehicle crews, and specialized troops. Though less powerful than the Garand, the carbine offered semi-automatic fire in a compact package that weighed only 5.5 pounds compared to the Garand's 9.5 pounds. Americans could afford to develop, produce, and field specialized weapons for different roles, while Japanese forces standardized on single rifle designs to simplify production and logistics. The technical assessment extended beyond rifles to examine American machine guns, mortar, grenades, and other infantry weapons. At every level, American equipment demonstrated superior firepower, reliability, or both. The Browning automatic rifle, carried by squad-level automatic riflemen, provided sustained automatic fire that supplemented the M1 Garand's semi-automatic capability. Japanese squads relied on Type 96 and Type 99 light machine guns that offered excellent performance but existed in much smaller numbers due to production limitations. Lieutenant Yoshikawa Eiji, Kurosawa's assistant, compiled comparative data from battlefield reports throughout the Pacific Theater. The pattern repeated on every island American units demonstrated firepower superiority that allowed them to overwhelm Japanese defensive positions through sheer volume of fire. Japanese troops fought with desperate courage, often conducting suicidal charges against fortified positions because their weapons lacked capability to suppress enemy fire sufficiently for tactical maneuvers. The much-celebrated fighting spirit of Japanese soldiers became a necessity rather than a choice when outgunned so dramatically. Close combat represented the only viable tactic. The report concluded with recommendations that Kurosawa knew would be ignored. Ideally, Japan would develop and field semi-automatic rifles comparable to the Garand, increase ammunition production threefold, expand weapons manufacturing capacity substantially, and retrain infantry in tactics that leverage superior firepower. None of these recommendations were feasible. Japan would fight the remainder of the war with weapons designed for an earlier era, asking its soldiers to compensate through courage and sacrifice for technological deficiencies that no amount of spirit could overcome. 8th of July, 1943, Colonel Hattori Takashiro reviewed intelligence summaries in his office at Imperial General Headquarters, trying to derive strategic implications from tactical realities that grew more grim with each passing month. Hattori served as a senior operations officer, responsible for translating battlefield information into strategic assessments that guided high-level decision-making. The accumulated reports about American weapons superiority, particularly the Iemjao's dominance over Japanese small arms, formed part of a larger picture that suggested Japan's war position was deteriorating faster than most senior officers publicly acknowledged. The weapons disparity represented merely one component of broader American material superiority that manifested across every domain of warfare. At sea, American shipyards produced aircraft carriers, destroyers, and submarines at rates that exceeded Japanese construction even before accounting for combat losses. In the air, American aircraft factories delivered fighters and bombers in quantities that allowed for numerical superiority in every theater, while Japanese aviation struggled to replace losses. On land, American forces deployed tanks, artillery, trucks, and engineering equipment in abundance, while Japanese units often moved supplies by hand due to vehicle shortages. According to strategic analysis referenced in H.P. Wilmot's The War with Japan, the period of balance, the industrial production ratios between America and Japan had reached levels that made prolonged conflict mathematically unwinnable for Japan. In steel production, the ratio was approximately 12-1. In oil production, the disparity was even more dramatic. America produced 60 times more petroleum than Japan controlled, even including conquered territories in the Dutch East Indies. In virtually every measurable category of industrial output, American advantages ranged from 5-1 to over 20-1. These macroeconomic realities shaped tactical decisions in ways that American commanders could exploit. Japanese forces had to carefully husband resources, restricting ammunition expenditure, minimizing fuel consumption, and avoiding attrition battles where material would be traded roughly equally. American forces could afford attritional strategies, using superior firepower to inflict casualties while accepting losses that could be replaced through enormous reserve manpower pools. The M1 Garand exemplified this approach. American tactical doctrine emphasized overwhelming firepower rather than ammunition conservation. Hattori had studied German military theory extensively and recognized that Japan faced challenges similar to those confronting Germany. In the First World War, a technologically capable but materially outnumbered force fighting against enemies with superior industrial capacity. The difference was that Japan's technological capabilities were significantly inferior to American technology, creating an even worse strategic position. Where Germany had fielded weapons generally comparable to Allied equivalents, Japan entered Pacific battles with equipment that was often a generation behind American equivalents. The personnel implications troubled Hattori as much as the material disparities. Each Japanese soldier killed represented a loss that was difficult to replace. Training took time. Japan's population was significantly smaller than America's, and industrial workers could not be spared for military service without further reducing production. American forces, by contrast, could absorb casualties that would cripple Japanese units because the manpower pool was so much larger and the training infrastructure so much more developed. A single American infantry division that suffered 50% casualties could be reconstituted with replacements in weeks. A Japanese division suffering similar losses might never regain combat effectiveness. Major Tsuji Masanobu, a staff officer known for aggressive tactical planning, argued during a strategy session that Japanese forces needed to change their approach fundamentally. "We cannot win attritional battles," Tsuji stated bluntly, an admission that would have been career-ending 2 years earlier. "Every engagement where we trade casualties roughly equally represents a strategic defeat because they can replace their losses and we cannot. The Americans understand this, which is why they seek decisive battles where their firepower superiority maximizes our casualties while minimizing their own." Hattori examined battlefield reports from recent engagements on New Guinea and in the Solomon Islands where American forces had employed tactics specifically designed to exploit their weapons advantages. Rather than frontal assaults against entrenched positions, American units used artillery and naval gunfire to pulverize defensive areas, then advanced behind heavy supporting fire from rifles, machine guns, and mortar. Japanese defenders, pinned down by suppressive fire from M1 Garands and Browning automatic rifles, could not maneuver effectively or concentrate fire against advancing troops. The tactical result was predictable high Japanese casualties, relatively low American casualties, steady territorial gains. The strategic implications pointed toward inevitable defeat unless circumstances changed dramatically. Japan had gambled that early victories would create a defensible perimeter that America would choose not to assault, leading to negotiated settlement. Instead, American forces methodically advanced through the Pacific, accepting the casualties required to capture each island, knowing that their industrial and manpower advantages made ultimate victory certain if they maintained the offensive. Japanese strategy had failed in its fundamental premise. America proved willing to fight a prolonged war and possessed the resources to win such a conflict decisively. Hattori's report to the General Staff outlined these conclusions carefully, knowing that such pessimistic assessments were unwelcome at a time when national propaganda still proclaimed inevitable victory. He recommended consolidating defensive positions, abandoning isolated garrisons that could not be supplied, and preparing for a fighting withdrawal that would maximize American casualties even as Japanese forces retreated. 15th of August 1945, General Douglas MacArthur stood on the deck of the USS Missouri in Tokyo Bay as Japanese representatives, signed the instruments of surrender that formally ended the Pacific War. Among the personal weapons stacked on the ship's deck, surrendered by Japanese officers as part of the ceremony, were numerous Type 38 and Type 99 Arisaka rifles, the bolt-action weapons that Japanese infantry had carried throughout the conflict. In warehouses throughout Japan, American occupation forces would eventually collect millions of these rifles, tangible evidence of the industrial and technological disparity that had shaped the war's outcome from its beginning. The M1 Garand had fulfilled the vision that John Garand and American weapons designers had pursued for decades, a reliable, powerful, semi-automatic rifle that gave American infantrymen decisive firepower advantages in combat. General George Patton would famously describe it as the greatest battle implement ever devised, a characterization that acknowledged the weapon's contribution to Allied victory. Over 4 million Garands had been produced during the war years, equipping American forces on every battlefield from North Africa to the Philippines. According to military historians' assessments compiled in Larry Ruth's War Baby, the U.S. caliber .30 carbine, the M1 Garand and its companion weapon, the M1 carbine, together represented the most significant small arms innovation of the Second World War. The Japanese engineers who had examined captured Garands in 1943 had reached accurate conclusions about their forces' disadvantages, but their warnings had come too late and in circumstances where solutions were impossible. Japan's industrial limitations, resource shortages, and overstretched military commitments meant that even perfect understanding of American weapons superiority could not generate effective responses. The Type 4 and Type 5 semi-automatic rifles remained experimental curiosities, produced in tiny numbers that had no impact on the war's outcome. Japanese soldiers continued fighting with bolt-action rifles until the final surrender, compensating through courage and sacrifice for technological deficiencies that no amount of fighting spirit could overcome. The post-war assessment of Japanese weapons development revealed the extent of the technological gap. American technical intelligence teams examining Japanese military research facilities found numerous promising designs that had never reached production due to resource constraints. Japanese engineers had understood modern weapons technology, but lacked the industrial infrastructure to implement their knowledge at scale. The contrast with American weapons development was stark, where American designers could move from concept to mass production in months. Japanese designers watched viable designs languish for years without resources for full-scale manufacturing. The legacy of the Garand extended beyond World War II. American forces carried M1 Garands through the Korean War, where the rifle continued demonstrating effectiveness against Communist forces equipped with Soviet bolt-action rifles and early semi-automatic weapons. Not until the adoption of the M14 rifle in 1957, and subsequently the M16 in the 1960s, did the Garand finally leave American military service. Even then, thousands remained in reserve stocks and the rifle continued serving with Allied nations for decades. For Japan, military defeat led to comprehensive reconstruction under American occupation, including transformation of the nation's industrial base. The same manufacturing precision that had been insufficient for wartime weapons production would eventually make Japan a global leader in